Welcome to ClickMyProject.com.
Now we are going to discuss about the product brain MRI image classification for cancer detection using deep wavelet autoencoder based deep neural network. Now we are going to discuss about the abstract for the process. Brain lesion segmentation and classification are an integral part of both computational intelligence and pattern recognition process. In this process, efficient algorithm was implemented in segmentation of the lesions region. It is carried out and its features such as LBP combined with the GLCM to extract the data from the image. Hence, this is the process to extract the feature data, and then in segmentation, a morphological based fuzzy C-means clustering is proposed for the clustering of the particular region. Then this process involved here in medical field to detect the brain lesions and its features classification method using the CNN, which helps to classify the severity of the brain input. Along with this process, the performance will be evaluated to evaluate the efficiency of the process, and then by using the performance we can justify our process is efficient or not. Now we are going to discuss about the flow diagram for the process. This is the overall workflow for this process. At first, the step is the input image. The input image is getting from the dataset. After getting the input image from the dataset, the pre-processing will be carried out. In this pre-processing step, we have the two kinds of stuff. First one is the image noise filtering, then the second one is the grayscale conversion. In this filtering method, if the noise is present in the input, means it will be filtered by means of the filtering method. After the noise filtering, the grayscale conversion is used to convert the RGB image into an grayscale format. After converting the RGB to grayscale, the segmentation will be carried out. This segmentation is helped to extract the region of interest, that is the lesions regions. Here the MFCM algorithm is used to segment the region of interest. After segmenting the region of interest, the feature extraction will be carried out. In this feature extraction method, we have to generate the test feature by means of two feature extraction methods like LBP and GLCM. LBP stands for local binary pattern, and then GLCM stands for the gray level co-occurrence matrix. By using these two algorithms, we have to concatenate the features of these two algorithms to form the test feature. After generating the test feature, the CNN classification is applied to classify the input is lesion or not, or if the lesion is present in this, means which kind of lesions is present. So here we have to give the three things as an input for this classification method. The first thing is the test feature, then the second thing is the train feature, then the third one is the labels. By using these three inputs, we can able to classify the results. After the CNN classification, the performance will be evaluated by means of the accuracy, sensitivity and specificity. By these three parameters, we can able to justify our process is efficient or not. Now we are going to discuss about the initial running procedure for the process. At first, open the MATLAB 2015B and change the current directory. If you want to execute the code, means just right click in the main_GUI.m and select the option run. Now the initial GUI was opened. In that you can see the several axes in the left side for the display purpose, and then the several push buttons in the right side for the controlling buttons. Now first click the input image. After clicking the input image, you have to select any one image from the dataset. After the selection of the input image from the dataset, the corresponding image will be plotted in the axis 1 with the title input image. After displaying the input image, we have to pre-process the input image. After clicking the button pre-processing, the image resize will be done. In this image resize, the image is resized into 256 x 256. This 256 represents the number of row and number of columns. After resizing the image, the filtering is carried out After the filtering, the grayscale conversion is carried out. If the input image is an RGB, means it will automatically converted as an grayscale image. Then the click segmentation button. After clicking the segmentation button, the segmentation will be carried out by means of the clustering method. Once the clustering was done, here we have an 4 type of clusters. The appropriate cluster is cluster number 2. So here we have to enter the 2 and then give the button enter. Now the segmentation label index image is shown in this axis, and then segmentation result is shown in this axis, and then the contoured region is shown in this axis. After the segmentation, feature extraction will be carried out. In this feature extraction module, we have to show the features of LBP, GLCM and CNN. So first of all, extract the LBP features from the image. Now the features of the LBP is shown in this table, and then the corresponding image is shown in this axis. After extracting the LBP, we have to extract the GLCM features. The GLCM feature value is shown in this table. After the extraction of the GLCM, we have to apply the CNN. Now the CNN features is shown here. After extracting the feature values, we have to classify. So here we have to click the button classification. Now the identify result as an class 4 type of disease, lesion. After the classification, we have to evaluate the performance. Now the performance will be evaluated by means of the true positive, true negative, false positive, false negative. By using these 4 parameters, we can able to calculate the accuracy, sensitivity and specificity. The values of the accuracy, sensitivity and specificity are shown here, as well as the corresponding value of graph is shown here.
Thanks for watching this video.